Hi guys, today we're going to talk about the rest of the topics for thermodynamics. And one of these last topics is heat transfer. So for example, let's say you're making some really delicious bacon um, and you have a skillet. Okay, so what's going to happen to your hand if you touch this skillet? Obviously it's going to burn. But why does it really feel hot? What's going on? What we notice is that heat flows from the pan into your skin. And again, why does that heat flow happen? Why does it happen that way? Well, it turns out that heat flows naturally from warmer objects, and these warmer objects have higher energy, to cooler ones which have lower energy. So we kind of talked about this yesterday a little bit with temperature. We said that is an average kinetic energy. So that means that the more energy I have, the warmer the object is. The lower energy, the cooler it is. So this is um, a really interesting topic, and the way I remember it from high school, that my physics teacher taught me was if you put your hand on top of the table, you'll notice that the table is usually cooler than your hand. Okay? Eventually, after maybe a minute or so, both you and the table reach an equilibrium, and this happens because your hand, which is warmer, it's moving that heat flow to the table. Okay, so heat transfer is the study of how heat flows. And heat flow can only happen if there's a difference in temperature. Okay, so you have to have something that where you go from high temperatures to low temperatures. Okay, and sometimes you'll see these diagrams as uh, pieces of metal or blocks, and so heat will always go from high to low. It doesn't matter if it's from left to right or up and down, as long as, let's say for example, if you had something that's 80 degrees versus 20 degrees, heat will flow from high to low. Okay, I could also have something like this, something that's 100 degrees Celsius here, but 20 here. So heat will always go from high to low. And so this brings us to the topic of thermal equilibrium. And this can only happen when you have two objects that have the same temperature. And so therefore no heat flows because the temperatures are the same. So for example, let's take these two pictures. We have one in thermal equilibrium, obviously because both are in the same temperature, so there is no heat flow. As opposed to the ones on the bottom. So we have something that goes from 75 to 50. We have high to low, and you'll see these diagrams a lot throughout the thermodynamics section and through tests or quizzes. And so, for example, if somebody were to ask you what happens if I put something that's 75 degrees next to something that's 50 degrees, what temperature could they reach? So, if anything, the hardest math you'll do for thermo is just adding these two to get an average and then dividing, which you get around 62.5. Okay. Same thing happens here. Okay, but now heat flow is from right to left because it so happens that the one that's hotter is on the right, so it's just from high to low. And again, if I were to take the average, it's the same thing. Okay. So what is heat? Heat is a flow or transfer of thermal energy. So you'll see these words interchange a lot, flow and transfer. So then what is thermal energy? Thermal energy is the sum of all energies. Okay? It's a little different from temperature. Temperature was the average of kinetic energy because with temperature we're dealing with just motion, so it's just kinetic energy, as opposed to thermal, which has both. So thermal energy depends on two things, that is mass and temperature. Okay. So for example, with mass, let's say you're trying to heat up um, a small container of water. Maybe you're trying to heat up something for your food. That's going to be way easier to heat up instead of trying to heat up like a pool or a lake. That would take way longer. And that happens because you have more mass. The more mass you have, the the more it's going to take to heat up. And that happens with anything, food, solids, and that also happens with temperature. So there's 3 ways that heat can transfer. Okay, and I'm probably sure you've gone through these, so let's go through these fairly quickly. The first one is conduction, which is the transfer of heat through materials by direct contact. So these materials can be solids, liquid, and gases, but with conduction, we really deal with more solids because you have to have some type of contact, and the more contact you can have with it, the better conductor it is. And so this brings us to thermal conductors, and these are materials that can conduct heat easily, and we find that these thermal conductors, as shown in the pictures, are mostly solids. So things like copper, aluminum, gold. And so these I would star these because this becomes very important for us, not only in thermal but in electricity. So it also happens that thermal conductors are good conductors of electricity. And that's our next big topic for the rest of the 6 weeks. Heat conduction cannot occur through vacuums. And why does this happen? And because vacuums are mostly empty space, and conduction needs something to touch, something that where particles are colliding, and so that cannot happen. Another example of what a vacuum is, if you've ever seen a thermos, they're called thermos, and you'll see that as a design where you may have a smaller bottle like this one surrounded by a bigger bottle, and so people could put things like soup, their food, or coffee. Obviously, because just the laws of thermodynamics, heat will want to somehow be released. It will be released, but it won't be released as fast as if you had it in a cup. Okay, this is why people use thermos if they want to keep their lunch hot and they don't have a microwave nearby, or when you're for example, in the winter times, maybe you want to keep your coffee warm. Okay, well, the thermos will help you with that because it will decrease that heat flow. Okay? It will keep your coffee warm. And so this brings me to one of my favorite shows, which is The Simpsons. One time in this episode, it's summer, it's very hot, and Homer gets this brilliant idea, which wasn't too brilliant, to open the fridge and cool off. So it works for a little bit. They're using the corn and the peas to kind of, cool off. But it so happens that this is not possible because remember, heat flows from high to low. So what he's trying to do here is going from cold temperatures to the very hot house, and that's not going to work. And eventually you see the refrigerator goes out, the motor goes out. So this brings us to insulators. These are materials that conduct heat poorly. Okay, so things like foam, wood, or plastic. And plastic, for example, in this picture is very good because that means that you're not gonna hurt your hand when you're cooking. Okay. Somebody also talked about the Flash. I don't know if you guys have seen the Flash, but the character here, Barry Allen, he just he's running really fast, and this creates friction, creates heat. But not only that, he also creates electricity, and so he has to have a really good suit that is also a good thermal insulator. And so sometimes he might use things like ceramic also that can not only protect him but protect the people around him. You don't want to be shocked or be as soon as he touches you or something, burn you up. And so this is also a very important topic as far as knowing that air is a poor conductor of heat. Air is not that great. It doesn't if you have a down jacket, it'll help you keep warm. And that's because it's not going to absorb any cold, which is great. Next topic is convection. Okay, and this is just mostly through liquids and gases. Okay, and this is why I said usually when we think about convection, we'll think about liquids and gases as opposed to conduction, which we'll focus on with solids. And so a good example of this is putting your hand over a candle. We know that heat rises, and so if you really want to warm up your hands, you want to make sure that you put your hand over flame, not on the side. Heat is carried by the motion of air. So wherever the air is moving, that's where the heat will go. And so we saw this yesterday when gas expands. When gas expands, um, as occurs here when you heat it up, um, the balloon will move up. Okay, it's getting bigger, it's getting better. As opposed to if you make it cold, it's going to move down. And this also occurs in liquids. So if you're boiling water, you'll see these currents. Water that's cool will move down, whether as opposed to the hot water that will rise. Lastly, the last topic is radiation, and radiation you'll see it through these radiating waves, such as these and these. So if you see those waves, you automatically know that's radiation. So you experience radiation every single day, and one of these waves is through the sun. This is emitted by electromagnetic waves. Radiation can travel through a vacuum. It so happens that these electromagnetic waves are very small, and so they can travel through any space. So anything that is above a negative 273 degrees will emit thermal radiation. So us as humans, we do emit thermal radiation. So right now, if you're sitting next to somebody, you both are releasing radiation to one another. But don't worry, you're not gonna die from that. Your own body, because your own body gives thermal radiation. We see this glow when you see an infrared night vision camera, so you can see things like this. So lastly, thermal radiation can be absorbed or it can be emitted, and so this becomes very important in your real life. And lastly, when you have dark substances or objects such as asphalt, these things are going to absorb heat, and so this explains why you might not want to wear dark colors in the summer. It's going to absorb all that heat and you're going to feel hotter, as opposed to if you have something that's lighter color, it's going to reflect that heat off. It's going to take in, but it's going to reflect it off, so you'll feel cooler.